19 hours, a remarkable personal achievement. Inspired by these elements, HPCL continues to lead with innovations that protect our environment and uplift communities. Looking ahead, we are dedicated to forging a future where sustainability and progress go hand in hand, ensuring a brighter world for generations to come.
करके आया नया पल, नए पल में पलता हुआ वो नया कल, नया दौर ले करके आया नया पल, नए पल में पलता हुआ वो नया कल, बेला वतन में हर्ष है, महारत्न HP का स्वर्णिम वर्ष है, महारत्न HP का स्वर्णिम वर्ष है, नई भोर में नव क्षितिज पर है दृष्टि, जतन से रहे पंच तत्वों की सृष्टि, रही शक्ति आयु नवादिनी जय चिकरे मन में ऊर्जा गंसी, बड़ी सोच की दूरदृष्टि गगन सी, नवाचार अविरत पवन की लगन सी, धारा चुम्बती है खुशी में मगन सी, नवा से जो बहता तरंग, ये भारत नया है, ये भारत नया है, ये भारत नया है, ये भारत नया है।
In the bustling city of Mumbai, a legacy began in 1954. The Mumbai refinery came into existence as SO standard with an initial capacity of 1.25 mmtpa. The Lube India refinery followed in 1969, a joint venture between SO and the Government of India, producing 165,000 tons.
I request all the lovely members out here to kindly sit down and all the mobile phones on the silent mode before we start. A very good morning to all of you present here in this wonderful morning. I, Anchor Simran, welcome you all in this beautiful day, celebrating the third day of second International Conference on Green Hydrogen India 2024 together. And it's a time to start the panel discussion, and the topic for the same is strengthening the R&D ecosystem. And for the same, I would now like to invite our moderator out here on the stage, Professor G.D. Yadav, former Vice Chancellor of the Institute of Chemical Technology, Mumbai, and currently the Emeritus Professor of Eminence at ICT, Mumbai. Loud applause, please. And now I would like to invite our speakers. Let's start from Professor Dr. R.R. Sonde. We have here with us Professor IIT Delhi, Abu Dhabi campus, a very smiling face with all of us. Visiting Distinguished Professor, IIT Ropar, Adjunct Professor at IIT Jodhpur, IIT Jammu, IIT Gandhinagar. A big round of applause, please, everyone. I would now like to invite Mr. S.C. Chetal, ex-director, Indra Gandhi Centre for Atomic Research, ex-mission director, Advanced Ultra Supercritical Thermal Plant R&D, and ex-senior advisor, BHEL R&D. A big round of applause, please. I now request Dr. Sai Hoon Kim, technical advisor, Hyundai Motor Company, South Korea. Loud applause, please. And I would also like to request Professor Rajeev Ahuja, Director, IIT Ropar. He's one of the most highly cited researchers and top 5 material scientists in Sweden and India. So loud applause, please. I now request our moderator to kindly start the session. Thank you. Sir, you can sit there also. I'll provide the mic. Okay. Thank you.
Good morning, everybody. You know, one of the things I found here, it's a wonderful Bharat Mandapam. You can get easily lost. And you don't know where the tea or coffee is, because there is ozone also on the other side. And hydrogen and ozone can react, right? And produce water. So this water, I think, is very pure water. Jokes apart, this is a wonderful, morning rather, for all of us. And I'm delighted that we have such a wonderful panel with us. All of them are experts working in this area. Even I have been working in hydrogen area. We have been working on thermochemical processes for last 16 years. We have got several patents, developed technology for thermochemical hydrogen. Mostly people talk about electrolyzers. So let us, give some perspective. India plans to have 5 million metric tons of hydrogen, green hydrogen, by 2030. And the Indo-German collaboration, the Germans said they would like to have 10 million tons and they would like to, import some hydrogen from India. So we are in tremendous scale. And yesterday we saw Netherlands is saying the same thing. Australia is saying the same thing. So maybe there are many other countries which want India to supply technology or give hydrogen. So how do you do that? And we require niche technology. My personal, take on this is that we are committed to net zero by 2070. Then my next question is, why 2070? Why not 2050? Because Murphy's law, if you give a deadline, the work extends to that deadline, right? So we should say that we will also do 2050 like other countries, developed nations. Remember, last year we emitted 35.6 gigatons, billion tons of carbon dioxide across the world. And that if you want to maintain that 1.5 degrees Celsius temperature rise during this century, we have to bring down this concentration to less than 10 gigatons. Only then it is possible to have 1.5 degrees Celsius. Unfortunately, last year on 18th May, the World Meteorological Organization said that we are likely to breach this, this limit by 2027. That means we are in a real danger zone. And this year you saw what has happened across the country. Floods, droughts, rains, torrential rains. Delhi is witnessing rain, which then actually Delhi fellows must be happy also. Some rain is coming. But other parts of the country, and yesterday I also saw some news, Morocco and other places, it is torrentially raining. Then in America also. So what is happening to the world? So the climate change is a real business problem. And, I have been saying this in many of my lectures. Some of them are available on YouTube. I say, like we have in our Hindu religion, we say, I should not call religion, Hindu is dharma. So we say that Trinity, Brahma, Vishnu, Mahesh. This is a Trinity. For me, the scientific Trinity is solar energy, wind energy, and hydrogen energy. And hydrogen is going to be the savior of the world. In this Trinity, I give hydrogen, I call it as a prime Devas. Devas is a Sanskrit word meaning deity. Hydrogen is a deity. And why? Because solar and wind can give me energy, but hydrogen will give me also materials, chemicals and fuels and whatnot. And hydrogen will be the prime mover of decarbonization of this economy. See, almost, we normally talk about transport sector, that transport sector is highly pollutant. And many times people without realizing, I'm a chemical engineer, remember that, they blame chemical industry. They say these guys are highly polluting, which is nonsense, actually. Chemical industry does not contribute too much to the carbon dioxide as other industries do. Transport is one, buildings, almost 35% carbon dioxide comes from building, whether it is air conditioners or heating, Western countries. Then we have fertilizer, we have agriculture, name it. Shipping industry contributes something like 3 to 4% of CO2. So there are sectors of economy which need to be decarbonized. So our approach in India, because we are talking about research, ecosystem, our approach should be two-pronged. One is that wherever it's possible, we should not be looking at net zero. Net zero is not a good idea. I'm telling you that. As a scientist, I'm telling you. It is net negative, which is a good idea. We must take carbon dioxide out of our, energy mix. So all our energy should be renewable energy. And in that, hydrogen will have a very, very important role. So by 2050, it is believed that we require 49,000 terawatt hours of energy. 49,000 as a world as a whole. And in that, we have to plan something. My personal belief, my advice to the government will be plan for 10,000 terawatt hours. Then only, and we should be an energy exporting nation rather than importing. We should not be dependent on Middle East. Okay, so it is better that we develop. Of course, for that, there is another important parameter, that is water. Water is going to be a very important thing for hydrogen economy. So we have to have water supply. From where we get it, how we purify it, whether you do RO, you do something else. Now people are talking, they can make hydrogen by using seawater and all. But of course, you have to take out the ions from there. So this is a very big sector. Another prediction is there. That is, this prediction varies. Like this McKinsey report says 539 billion metric tons will be required. I don't know how they came at 539. Why not 540? Because it's a prediction, right? But somebody else says, 840 million metric tons. In other words, hydrogen economy is going to grow. So hydrogen has its own charm. Hydrogen is a lighter gas, which is 14 times lighter than air. So people think hydrogen is like, a hydrogen bomb. It is deuterium, but people believe that there is no safety. So concern is what? Not only production, storage, transport, but safety. These are the issues which we need to consider. So our research ecosystem, which we are talking about, this has to be by various, institutions. There must be partnership. Okay, they must develop this, and technology must be developed. And remember, one of the other words which you always hear on television is India will be third largest or second largest economy by 2047 when we complete 100 years of independence. That is not going to happen unless we have 24% growth in industry, manufacturing sector, and 70% growth in the so-called service sector. Only that computer is not going to give you, manufacturing. So manufacturing has to be promoted. At the same time, other nations, yesterday I also attended the Dutch and the Australian, they say they are giving incentive to their industry for green hydrogen. One said €2, another said $2 Australian. The Americans are saying one kg hydrogen in $1 in 1 decade. And what incentive they are giving? They are giving $3 per kg to the green hydrogen. And what our ministry did, power ministry, I'm sorry if anybody is from power ministry, don't beat me when I come out. They are giving 50 rupees, 40 rupees, 30 rupees. What is this? You should give at least 150 rupees, 120 rupees, and 100 rupees. Why I'm saying that? If we promote our industry, we can export hydrogen and we will get a lot of foreign exchange. That is the idea. And we should not be caught unaware. Like in the previous revolution, so-called industry 3.0 or 4.0, we lost many things. So we should not lose on hydrogen economy. This is where research, innovation, all those things are required. And my panel is going to debate that. Okay. And there will be tea or coffee after this. There will be some lunch, right? So close the door and don't allow anybody to leave this room so that they remain here. They understand why we are talking about hydrogen. Although we're talking about green hydrogen, blue hydrogen, what will be there in 2050? Only 2 hydrogens. Blue hydrogen and green hydrogen. Somebody is also talking about white hydrogen. So CNN last year said, on 30th of October, you know what they said? Oh, there is white hydrogen. The reservoirs of something like 6 million metric tons to 250 million metric tons are available near Mali. Now that the Australian was also saying they have something, right? But anyway, that hydrogen production also requires money. So what should be the cost of hydrogen and how do you reduce the cost of hydrogen? Because electrolyzers, that technology will not give you less than $6 to $7 per kg, provided the scale is more than say 10, 20, tons per day. Okay. That is what it says. So anyway, we have to find out from our experts what sort of capacity should be there, what should be government of India's policy, and how academia, government institutions, including CSR labs, DRDO labs, and some other labs, what they could do, atomic energy, how they will help. One of the things we have forgotten in this greening, atomic energy is the cleanest energy, carbon-free energy. But unfortunately, there are all misconceptions. So we have to educate people also on this green energy, renewable energy. So my panel is going to do that. And so Dr. Sonde, since you came from abroad, you must be got some fresh ideas. Can you tell us what India can do in this sector?
Well, I mean, you asked me a very loaded question, and therefore I'm not going to wade myself into that particular murky water. But what I'm going to do is that taking on, thank you very much, Chairman, for doing this. I brought about 7 bullet points. What is that India can do? Okay, so I'll just note these bullet points for your response. They may be provocative, but it is definitely designed to be provocative. Okay, because it's a very important stage that this country is. As he is saying that next 2.5 decades, if we are going to reach that magic number of $30 trillion economy, and that too, we have to do it on a climate change obligations of whatever that net zero. India has got a huge challenge, which no other country in the world has got this challenge. So we have to be cognizant of the fact that what India is going to do will be very different than, we can't just mimic what others are doing. Sorry, I mean, don't get me wrong, but our challenges are 2 orders of magnitude higher than that. So let me go ahead with my points, which I have noted down, especially with respect to R&D ecosystem. Number 1, India is a sufficiently well-matured R&D as far as the Asian zone is concerned. Korea may be part of it because they've got good academic institutions. I mean, we build about 10 million graduates. We have got research institutions, CSRs, laboratories, public sector R&D, private sector. I've moved in all these places, but we have not delivered. And that is something which should actually be, we should hold a mirror that our this entire R&D ecosystem, which is supposed to be what is delivering this, has operated under suboptimal levels. Now, that requires a very different discussion. I know that Pratibha may be turning in her seat. Why is he saying this? Because our R&D institutions have not delivered what is required by the industry. So that's number one. And when we are saying that, and I'm willing for a debate, but that would take a whole lot of time. If that is true, and now we want to use the same ecosystem to build such a gigantic problem, I mean, this thing of hydrogen mission, how is it going to happen? You can't use an old tool to deliver a challenge which is going to be in $1 trillion. I mean, if you convert all this 5 metric million tons, we would need about 78 million metric tons by 2040, what everybody is saying. I mean, that would mean at least about 22% of our, because currently our energy is 10,000 terawatt hours, it will go to 30,000 terawatt. I mean, that's a different modeling work that we have done. So the question that I'm asking is that the problem is so big, so gigantic, and we can't be depending upon that everybody will come from outside and this technology will happen. So what do we do? That's the second question that I'm saying. Then what do we do? What is the model R&D ecosystem that India must follow? So what we can do, I can take an example. And I'll naturally take the example where I worked for my first 24 years, atomic energy. How was atomic energy built in this country? 70s, 60s, when technology was denied to this country. Please believe me, my dear friends here, that we built a technology. I remember I was a young engineer joining Atomic Energy, Bhabha Atomic Research Center. Mr. Chetal, Dr. Chetal is coming from there. And we were showed the iconic leadership. Go ahead and do this. Country needs pressurized water reactor. Country needs to develop the arsenal. So that is what now, so which means that do you feel that a mission oriented, not the mission means under some ministry, a independent autonomous institution, the amount of privileges I as a young scientist enjoyed connecting with everybody, all these companies were developed by atomic energy, whether it's a L&T or Godrej or KBR, everybody has worked on the shoulder of atomic energy and developed the public-private partnership, which has become a buzzword now. Now, can we go and look at that particular thing? But next question is, no, we can't do that. Why? Because when we built atomic energy, the challenge there was technology, but commerciality was not a challenge. Nobody asked us, no power is as expensive as no power. Famous Baba statements. So you could produce anything because there was a strategic content to that particular program. But in hydrogen, if I say that no hydrogen is expensive as no hydrogen, no, you're a mad fellow, get out of it. We want hydrogen at under 80 rupees a kilo. And therefore, we are not able to utilize this particular, whatever is the model is successful, which is copied by ISRO and many other people, but somehow it has now gone into a different level because we as engineers and scientists were not told about the commercial. We thought money will come from somewhere else. And then only when I joined the public sector and private sector, I realized, no, one part of my brain was not well developed, where I thought science is ultimately deliver everything. But I realized that science alone will not deliver unless you bring the commerciality. And therefore, that model may not work. So I gave you 3 proposals. Fourth one, I said, this model will not work. Then how do you really build this ecosystem for hydrogen? What should be the method by which we should do it? I have no solution, my dear friends. We should debate in this particular meeting. But what DST did to me, and I'm leading one of the valleys, Hydrogen Valley in Jodhpur, gave me 3 lessons, which I'm now working with them. Number 1, what India should do right now in hydrogen is take the current state of the art. Don't look at what is the better 55 kilowatt hours per kg. Go ahead and do that. Take the current state of the art, reliable operating system, build a complete value systems. And my dear friends, you'll find that it is not so trivial. Huge. I mean, PV connecting to water electronics is huge power electronics. You cannot be importing a rectifying transformer. You have to build your IGBT based, MOSFET based DC-DC control systems. then there's a compressor, then there is a purification, then there's a storage, then there's an ammonia conversion, there's a dispenser. Every plant you will realize that there's a critical item which are only 2 or 3 people in the world are manufacturing it. So what I realized is that number one, we should do system integration capabilities, what ISRO did. So I'm saying that we need to have a kind of a complex hybrid model where we become a system integrators, and system integration is a top of R&D. It cannot be considered as not as R&D work. So number one. Number two, and I stop here, important thing for this country. I think if you don't get it, we will not. When you talk about hydrogen technologies, it is not like a nuclear technology or a thermal power plant. You are not building huge plants with big vessels. It needs a fine fabrication. India does not have that rapid prototyping. If I look at what is a electrolyzer, it is nothing but a catalyst coating on an electrode which is on a roll-to-roll basis. And we don't have those facilities with the capability to manufacture, look at an X-ray diffraction, to look at every square millimeter of catalyst is morphologically properly put. I work in fuel cells, I work in batteries, I work in electrochemistry, and I find that unless we fine-tune our manufacturing, rapid prototyping, 3D printing, this is a huge R&D work that we have to do. So these are the things which is missing. And the last one is that, yes, we should go ahead with the new R&D systems, look at the photochemical, and there are many, many fundamental R&D which should be done, but we should look at it, number one and number two, and bring your commerciality, bring commercial aspects in R&D. Thank you very much.
Thank you, Dr. Sonde. Don't stand for any election.
You are giving me ideas.
Wonderful, very, very nicely said. Let us have an international perspective to this. And we have Dr. Kim here, friend from Korea. They have fantastic institutions there. The KIST system. I have visited and saw the 5 different institutions in that valley.
So there is in Daejeon, there is all the government institutes together, the nuclear and energy and almost everything. So yeah, we have a very good
you're a friend of India. I know that much. Yeah. Okay. So please tell us, you want to show some slides?
Yeah. Okay.
Go ahead.
Maybe this is better. This is better. Okay. I'm the only foreigner, I think. And I'm not, English is not my mother language. So, yeah. So I don't speak perfect. And, actually, I came here it is my second time in India, so I cannot hear the accent so clearly, so I only hear about 80%, but I can hear your passion. Very good. Yeah. So yeah, that's good. So actually, I worked for Hyundai Motor Company for 20 years. I was leading the fuel cell program, and I mass produced the world's first fuel cell car, and also the next version, Nexo. In Korea, about 35,000 fuel cell vehicles are running today, and about 500 buses. So, and Hyundai Motor Company has now established the production capacity of about 2,000 buses per year. So we'll translate all our conventional buses to fuel cell buses in the coming years. So now I'm retired, and I work as a technical advisor of Hyundai Motor Company. And I'm in the same time, I just became professor of Seoul National University this month. So thank you very much. Thank you very much. Yeah. So let me tell you shortly about what I think about the hydrogen industry. So Jeremy Rifkin has said that we had gone through a lot of industry revolutions, but these industry revolutions follow energy paradigm change. So when energy changes, the industry changes. So it's not a simple thing because we have to change everything. So it's not easy. And now we can use renewable energies. Now, if you see the periodic table, now the human technology have become to use electrons and the most small molecules, most fundamental molecules like hydrogen for fuel cell and lithium for batteries. So there's other technologies, but for mobility application, lithium batteries is the best one. And there is some, storage capacity of hydrogen, how it can work as methane, the natural gas. So let's go on correctly. So what I want to emphasize is, if you see the whole supply chain of, not the supply chain, but the whole industry, there is supply, hydrogen supply, storage, delivery, and demand. But not every country is developing hydrogen in the harmonized way. I'll tell you later. In Korea, we don't think about production. We're still using byproduct of hydrogen, and we have no capacity for green hydrogen. Yeah, but we only work for utilization, fuel cell. Yeah. Now we just start to think about developing electrolyzers. Yeah. So Korea have imported 97% of our energy from foreign countries. So we are not so familiar with energy, but we are good at using the energy. Yeah. And if India only, relying on, supplying the hydrogen, green hydrogen, and green ammonia, you have to also consider how to use it, because in order to export, it will take a long time. Even if you want to use hydrogen in steel production, it will take minimum 10 years because they are not ready. So at the moment, the only way to use green hydrogen is in the mobility sector and maybe ammonia production. It's easy. You can replace it easily. But other sectors, it's very difficult. You need other infrastructure. And you also need the storage way. You also need how to deliver to the other countries. You need ships. But fortunately, Korea has 3 big ship companies: Samsung Heavy Industry, Hyundai Heavy Industry, Hana Ocean. So they are already had orders for ammonia. So we can handle that. And storage, we can handle it, I think, in some extent. So how to connect from supply of hydrogen production to usage, demand is very important. Well, now I heard that in USA and Europe, there is some hydrogen, but 80% hydrogen has no customer. Yeah, where will you do that? So it's very, this imbalance is always there, but government should try their best to balance it. Yeah. Okay. This picture shows what is, what kind of disbalance is there. See, status of global hydrogen invest. So if you see this map, Korea and Japan is the smallest. Yeah, even they're smallest than the in India. Yeah, they're doing nothing in the big, large hydrogen production or chemical products. But see the hydrogen refueling infrastructure, refueling stations. Was 258, China 351, Japan 167. Total 787 stations, and whole Europe there is only 246. So Europe, they cannot use they have no usage of hydrogen. And USA only 70. Yeah. So it is unbalanced. They have problem. Yeah. So I hope everyone can make this balance. And let me tell you about the hydrogen techniques. So India wants to produce a large 5 million ton per year. Will make the electrolyzers. Yeah. In the world, there is only 2 gigawatt electrolyzer now operating, and more than half is China. So there is not many really commercially operating electrolyzers. So this is a start point. Yeah. And let me tell you my experience. I developed the fuel cell technology from the bottom, from the scratch. It took me 20 years to establish the whole supply chain. This is the components you have to have when you develop a fuel cell system. You have to have the stack. And in the stack, there's a bunch of technologies you have to develop. And balance of plant, compressors, humidifier, everything, sensors. There's a bunch of technology you have to develop and control. And you have to also have hydrogen storage system. So I had to develop more than 160 end components to develop one system. And I had to work with more than 300 companies. So this is almost same with the electrolyzer. So if India wants to develop new technology, they have to gather together. All the technology has gathered together, and someone has to lead it. And maybe Korea did this in 20 years, but Korea also learned from USA. The first system Hyundai used was UTC power system. You have to learn someplace and first copy or make, yeah. China is doing a lot of copies, but that is a good way, but not national-wise, company-wise, yeah. So you have to look at. So many people think fuel cell or electrolyzer will be expensive, then battery. So now fuel cell car is competing with battery cars. And people think fuel cell is always expensive. It is not the case. It is because battery was produced for a long, long time, and they already have all the production technology. Compared to that, fuel cell, no one has produced that much. But in this picture, in this file, I calculated all the raw materials, how much gram is in it. Yeah, plastic, steel, platinum, everything. And if you add fuel cell system and hydrogen storage all together, only the raw material cost, it is about $400. It's for 100 kilowatt fuel cell. And the battery pack, if you calculate all the raw material, this is a 70 kilowatt hours battery. It's also about $400. So the base cost is the same, but if you increase the range, fuel cell will be more cheaper because you only add hydrogen tanks. So I think fuel cell has the possibility to become competitive compared to the battery technology. Now, I will not talk, more about the automotive, but a battery. I think small cars battery is clearly better, but the big cars and relatively big vehicles, I think fuel cell have the chance. And now you probably heard Toyota and BMW is cooperating for the hydrogen car. Yesterday announced GM and Hyundai is cooperating for this hydrogen car. And soon there will be some announcement more. So now all the automotive company is developing fuel cell cars. Okay, and aviation and maritime, there is a lot of progress. So IMO just announced their safety guide in 22. So now we can design the fuel cell system for maritime application. And their target is to be net zero by 2050. So it's good. And for aviation, for even small UAM, it is difficult to use battery. You can only fly 20 minutes. So if you want to go far, you have to use fuel cell. And fuel cell, and I talked with Airbus people, and Airbus doesn't have idea to use any battery because battery is very also dangerous and heavy. Yeah, so their target is to produce 100 passenger airplane by 2035. This is my summary. So in the future, energy will come from solar, wind, and nuclear, and you will use seawater. So you need water desalination because you have a long coast. You can have water everywhere, and you can have sun everywhere or wind everywhere. So you have to use electrolysis technology and compress or make it in ammonia, and you can deliver it to other countries, use it by yourself. Maybe the natural gas hydrogen, maybe, I don't know. I'm not clear, but maybe there is some. And in the mobility area, battery, fuel cell, supercapacitor will be combined and make the powertrain in the future. So I put the circles here to to the desalination or water purification and electrolyzer and fuel cell system. This is the three technology German government said this is the core in their hydrogen strategy. So we have to first try to make electrolyzer, fuel cell, and water treatment. Yeah. Thank you very much.
Thank you, Dr. Kim. Very interesting. So, perhaps you might have read it somewhere. They used to say battery will be new oil, right? Fuel cell. I say carbon dioxide will be the new oil, and I'll tell you why. Okay. Next is our friend Dr. Chetal, whom I know for a number of years, IG car director. Dr. Chetal, what is your take on this? You can sit or you want, well, you don't have to go there. Okay, all right.
Good afternoon, my dear friends. Over 54 years of experience I have in atomic energy, 41 years. I have seen the public sectors and I have seen the private sectors. I will share with you the difference in the R&D in the three systems actually. Then I will share with you on this topic also. In atomic energy, we do not believe in getting anything from foreign countries. The blood is we can do in India, we will do in India. We do not hesitate to have a discussions on technical subjects, but we are dead against buying an item from foreign countries. That's the reason that we have in the nuclear sector, where I have spent 41 years, absolute clean from A to Z we can do in this country. We might be a little slow because of the resources. We are very few, we are one of the few nations where we do everything in the country. And many of you may not know that we take one basic approach, that we do not mind importing the raw materials. But in case a foreign country tries to twist, we can do in this country. For the reactor for which I have worked, we needed very large size plates. We have never done in this country. But first time we have done 8 meter by 3 meter plates at Rotterdam steel plant because we were not sure whether somebody will twist us from outside. When I was young at 27 years, I had the opportunity to be a part of a team. I was leading the team on import substitute for our steam generator safety devices. After doing the work, when I told my director that 50% we can import, 50% we'll put in India, he said, Chetal, 50% confidence which you do not have, I have in you, we would not import anything. This is where I see the change of the R&D in the government of India atomic energy, where people at the higher level are putting confidence in you. In spite of that you may be having some fear that you have done an item at 1/5 price. How will you do when somebody is giving with a higher price? When I come to the private sector, I was independent director of Tata Power Solar, one of the subjects and all that. I have seen a change. The simple question is, if I put money X in how many years I'll get 3X. They do R&D, and when they do R&D, they don't do in a system like that where the time overruns, cost overrun. It is absolutely on daily basis. They know that they will deliver it. So there is one advantage in the private sector is that they mean business. If they put money, they will get the job done. In the public sector organizations, which I have spent considerable time, unfortunate part are two parts. There is a fear that if they don't succeed, they will be liable to actions. If they don't do anything, nothing to worry about. I have seen that, and I have brought some change also because as a mission director, I had enormous money with me. Money was not the issue. Under compulsive technology, we can do everything in India. Under compulsive technology. I will just share with you an example. We had a 20-ton casting in nickel-based alloy. Fortunately, the foreign offers got rejected on commercial grounds. We made the same casting in BHEL 21 ton, world's heaviest casting. For the simple reason is that I took the responsibility that if it doesn't come well, I take the responsibility. Let BHEL not worry, it's a R&D system. In R&D, one must accept in challenging jobs that there might be some failures, but the team will be competent to overcome the failures also and give you a successful product. In 2011, when we were trying to make the nickel-based tube for the first time in the country at our own unit and nuclear fuel complex, My metallurgy had told Chetal the tubes have cracked. I said, nothing to worry. We have learned how not to produce the tubes. And after 3 days, we made the tubes all right. So question is that this country can do everything. We need directions and people should have confidence on the system. Now, coming back to the subject proper, what I feel that there are positive parts of what we are doing and there are concerns also when I see that. The positive part is that the ministry, the DST, everyone is working very hard and we are very proud that we are looking forward to export the hydrogen one fine day. But what is happening, all the PLI schemes and all that, everything is going to the foreign country with an Indian name on it. We need to bring some change in the system. So that is what I would like to submit to all of you. The changes which I find and the fears which I have got. I must say that I have in some association with DST. DST has successfully brought a system of tier level 4 or 5. But that is not the end. What is missing is that today we have a chain of projects of level 4 and 5. How many of them have really become industry-oriented projects? Time has come to convert the R&D with less breadth and more depth. Take few projects and bring to tier level 8 on the indigenous technology. We talk about the electrolyzer. Nothing is in India at the stage what foreign countries have. It is not the India cannot do. Question resources have to be put. We are trying to put too many resources in doing everything on the earth, but then we do not succeed because we have limited resources. A country like Korea, I have an opportunity to spend some years there also on their nuclear energy. And they have more funds than what we can have, but they deliver it. Funding is one difficulty in the country. We must utilize our resources in the best possible manner by doing few projects, indigenous technology to the last stage of tier level 8 and try to minimize too many projects of level 3 and 4 and living on the system. And I would like to share what I am looking for this list of 7-8 projects. We must look for a 5 megawatt electrolyzer made in India. We have many organizations which can do, including atomic energy also they work. But the question is we are working on 100 kilowatt, 200 kilowatt, all that. It is not that we cannot build 5 megawatt. Question is resources. Our funding for the sum of the projects should be on in level industrial scale so that we are able to see what I say. It's time to see our own creations. So similarly on the fuel cell 100 kilowatt, we are working on 25 kilowatt. We say we'll make 25 into 4. That is not the way to tell somebody that my 100 kilowatt is 100 kilowatt, but internally it is 4 into 2. It will not be. Coming back to the issue of hydrogen, where I beg to differ with the entire country's approaches. We are talking about green hydrogen coming at $6-7, just now our moderator told us. Every country in the world makes best use of their resources. It is time India should look for production of hydrogen from coal. It may not be green, then you can put CCUS. Today, we need to start making use of the hydrogen. City gas distribution in the country, we can do blending in hydrogen. Let us try to make a feel to the entire country that there is a use of hydrogen. We should try to make hydrogen usage on a large scale by blending. Today we talk about 3-4 organizations. Somebody is doing 2%, somebody doing 5%. World has gone to 12-15%, targeting 20%. We should do R&D on that area and go to the last part. So these are the areas where we should work. And last part I would like to submit that if we want to succeed in the R&D based on my experience, we need few things. All these projects should have a mission director for all these projects. 6-7. First part. A very rigorous project review monitoring committee for every project. Third is the high-level committee which meets once in 2-3 months just for 1 hour. What has been done and what has not been done. Only 2 slides. When I was mission director, I used to show only 2 slides. What has been done and what is concerned to me. Somebody has delayed, some CMD has delayed, BHEL, NTPC. Take them to task and get the job done. Over. So we need to be very clear, and I will also like to submit the last part. We need to change our procedures actually. Funding, once you give, it should not come in the way. Procedures in public sector organizations I have seen, if there is one offer, you cannot handle it. They say next time if you get one offer, then it is allowed. Only first time it is not allowed. Actually. Yeah, so we need to change the procedures. This is what I wish and look forward that our nation should do this hydrogen ecosystem in India. We can definitely take the help of foreign, but let us try to do in a way that we feel proud that this nation can do, and we do it. Thank you very much.
Dr. Chetal, thank you so much. I will make some comments because instead of doing at the end, what is most important in any energy sector, particularly since we are talking about RE and all those things, is the government policy. And if there is a policy paralysis, then you cannot do anything. I tell you another issue which you said, that we don't trust our own brains. We want to import technology because we think they are superior to us. And, the funding of research projects and all, yes, wherever there is a TRL level, that so-called R&D and D, research, development, and deployment will go from 7 to 9. The industry has to be a partner. So my personal belief is that we will get money from industries only because they are the beneficiary and the society at large. So what we should do, we have this so-called CSR, corporate social responsibility, 2%. They have to do, everybody has to do that. Make it 3% and give 1% extra to the research institutions and ask them to develop technology, and that technology should be shared, the IPR should be shared with that particular industry, and then you can become an exporting nation. And there is no limit. So higher educational institutions, whether they are in private sector or government sector, they should compete for that 1%. That is a lot of money. Because government has other programs and they may not be able to spend everything on research and innovation. We may talk, and we will be, in 2050, we'll be 1.67 billion people, remember. So we are a lot of people. So this is what is required. And the last point you talked about was the coal. Underground coal gasification, there was committee. I was a member of that. So if you take hydrogen out of coal, you have to, of course, talk about the carbon decarbonization, carbon capture, utilization, storage, whatever. We don't have so many reservoirs to store it. So that means we have to convert that carbon dioxide into something else, that is fuels, chemicals, and materials. Okay, like methane, you make methane, carbon dioxide to methanol, or dimethyl ether, or formic acid. These are very good sources of hydrogen. So e-methanol, what we call, or green methanol. So that is also one of the things. Then the entire world will not have coal more than for 200 years. So it is again biomass. So biomass conversion into chemicals, materials is again by water splitting. That is hydrogen and oxygen. So I support your idea that we are capable of doing it, but we have to do it fast, and we should be accountable for the money which is given by the public. The industries will take you to task. They don't give free money. You said 3x. No, they want 100x. 3x is not the formula. They want, if they spend $100 on you, they will want, $1 lakh. Okay, that is what is going to happen. So, Dr. Ahuja, you have stayed abroad. You are in India. Now you have experienced both the systems. So your views will be very important for our discussions here.
So first of all, I would like to thank DST and MNRE to invite me here. As you have listened already, the 5 learned people, sorry, 4 one, and maybe I will not give you much more gyan. So I'm living outside India for last 32 years. So working in European countries, especially I'm faculty in Uppsala University in Sweden. And I joined here as a director 3 years back. So what we are talking, we talk, I'm also Indian, we talk too much. So we can give a good speeches, but how we can put in the reality, that's missing. We talk everything, policy, government. I was in Europe, I was in Sweden for 32 years. We never talk about what I want from the government. So we have to generate ourselves also. And of course, the government will come in the picture. They will put money in your system. And in India, when we are talking about hydrogen, we are talking, I think, for a long time. And maybe Professor Vijay, you know that we are talking for a long time. And we are still talking. Whereas in Europe, when we talk, we deliver. So we have a group of more than 100 group is a European network on hydrogen storage, production, and uses. And we are the part of that one. And I was leading the materials part in the European, that cluster of 100 groups from different European countries. Mostly was from Germany or France or Denmark. So we have to bring that kind of culture. So we are talking about storage, we are talking about transportation, we are not talking about materials. And everybody say that hydrogen is so light, but it's the most nastiest element in the periodic table. It interacts, it moves so fast, it's interact with everything. And we have to find the materials. How we can avoid this interaction so it cannot damage the material which I am using. We are talking about cylinders, hydrogen gas for cylinder. We are talking about 700 bar cylinder. So maybe we are using, still want to use steel or carbon fibers. But if you want to use steel, that's a good idea. And when we are talking about here, when we are here, we are talking about research and development. Most of the research in India is done in the university level or in IITs. So most of these are the basic research. So we have to couple the basic research to the technology that we are lacking. We are doing good projects on the basic level, how we can take to the next level. When one of our speakers was saying that we have to take to TRL level 9, or sorry, 8. But problem in the Indian system is that suppose I try to make a hydrogen cylinder and I will not succeed. We don't have indigenous 700 bar cylinders. So we are trying to make it. I can take example because I come from IIT Ropar, so that we are doing. And we are failing because there is no know-how in India. But people take that failing is that, okay, this is, you cannot do it. But when you try, you fail, then you can achieve. So we have to encourage those kind of research. So we have to take risk in research. And we have to give them opportunity, especially our young people, to take the risk. Because old people cannot take the risk. Young people can take the risk. So we have to encourage them. And I was in another talk in the morning in plenary talk. So they were talking about transportation of hydrogen. And they said that, okay, do we have infrastructure? And there was a discussion that GAIL has this gas pipeline, so they can use for existing, for some extent for hydrogen distribution. So again, we have to think again material aspect. When the hydrogen will go with that pipeline, what will happen to that material? So how the interaction of hydrogen will exist, will react with that kind of material. So storage is also, when you talk about GM, so I was your world-class university program professor in Seoul. And I was the initiator of the IBS program, what you have in Korea, in NRF. I have 2 of my students from Korea. They're working on hydrogen in Korea. So Korea, when we talk about Korea, because Korea doesn't have their own energy, so they are importing everything. So they are keen. So they have a lot of pressure. So we should also feel some pressure to do that. So if a small country like Korea can do it, why we cannot do it? So this is the thing we have to think about. And then we were talking about the ecosystem and hydrogen ecosystem we want to make. And there was, in the morning, people were saying that there was a talk by German perspective. They say we don't have manpower. We don't have skilled people who can work in this area. So skilling part, when we're talking about manpower, that India has. and how we can work with our educational institution like IITs, NITs, or universities to bring them on the board. And we should make work like in a consortium, like we have in Europe with the different European countries. Why not within India? We should have a consortium where IITs, NITs, and universities should be the equal stakeholders. And then we should talk about industry. When you talk about CSR, you're talking about 1%. So one of the speakers says that, Yadav, you say rightly that they will give you $1, they want $1 million. It's not. So they don't trust you. So industry doesn't trust academia. This is the problem. So we have to create that trust. So this is how I can create that trust when I can deliver on time. If I promise something, I have to deliver on time. And now we have when you get a funding in India, so as we are mentioning, there are a lot of conditions, a lot of rules to buy those things. It takes a lot of your time, a lot of energy of a researcher to put on that aspect. So we have to smooth that process also so that I can buy if I want something to buy, like I'm in Europe. I never thought about I have to go through this process or this big files, signing all the file. So as a director, I can see that how much file I sign. But this was nothing like this in Sweden. So we want what we want, we buy it from our grant. So this was so easy. So we have to bring those kind of system in the place, and we have to work more for materials. And if you look at in IIT system, I'm coming, within IITs, material science and metallurgy department has the lowest priority. As a parent, I want to send my kid in a computer science. When parents come, what is the package? So then they decide which branch they will go, which IITs they go. So we have to promote the material science. I can tell you when I'm in Sweden, my research group is still Sweden. We always talk about materials. I never talk about computer science or IT. We are making a service industry. We are not making a manufacturing industry. So we are talking about green hydrogen. That's a good initiative. First, we have to generate the domestic demand. We cannot rely on the only export. When you want to export, there are a lot of other logistic problems will come. So we have to reduce the cost. How we reduce it? This is again a challenge. And how much government can put the difference? Because that's what I was seeing, that the Netherlands or Germany is putting those difference in the cost from the government side. So we also need that kind of support. And industry and industry and academia should work together. And don't forget about the basic science. When we talk about Europe, now everybody is talking on that Asia want to supply to Europe, Africa want to supply all hydrogen to Europe. Why Europe? So Europe is a small continent. Why we all want to supply? And Europe has developed their own R&D sector, and that was only based on the basic sciences. So we should not neglect the basic sciences. That will help us to develop a materials or pathway to produce a green hydrogen and how to store that. Like GM want to go for the Chemisov system in the beginning. It doesn't work. Now they're all going for a Chemisov system, even GM and Hyundai also. So it's a continuous way. We learn that when we're talking about hydrogen-driven car, that Chemisov system is not going to work. We went for Chemisov system now. So this is a continuous learning process. So as I told you that I will not give you much more gyan. And we have to think about materials. And we have to work together with industry. And that's the only way when industry and academia and the different institutions will work together. That's a problem. So we have to change our mindset. We should not be individual persons. We should not think each other as our competitor, but work in a team. Thank you very much.
Thank you. Thank you, Professor Ahuja. You hit upon the right point. materials, particularly hydrogen, the embrittlement is very well known. And so even if they want to use the natural gas pipeline, there are reports where people have used up to 20% hydrogen. Okay, and safe. So natural gas, hydrogen, so-called SNG or whatever, so mixture, it will increase the calorific value and also it will be good for the environment. But you rightly said that material, and even otherwise, we see there, we only deal with the type 2 cylinders up to 200 atmospheres. Type 3 and type 4 cylinders, we don't have at standards 350 atmosphere or 700 atmosphere. So 350 means at least I should have 450 storage. 700 means at least 900. And this is where the carbon fiber or the resins, we are not making it India. That particular industry should also be given PLI scheme. It is not only the pharma and other guys. This industry also requires PLI, okay, which is missing in there. So Professor Ahuja, thank you very much. And you said something, students, everybody wants to be computer science and engineering graduate. Parents are responsible for that. And the headlines in newspaper, you guys put so and so IIT student got 1.5 crores. The parent thinks that my kid is Buddhu, he's not getting 1.5 crores. That is another problem. We are unnecessarily exaggerating things where we should say that every branch of science and engineering is required for the hydrogen economy, whether it is biohydrogen or with a electrolyzer or thermochemical. People don't talk about thermochemical, but thermochemical is equally important. So chemistry also plays, and then you are talking about biomass to hydrogen. Okay, so all these things are important for the country, and so ecosystem should be there. You rightly said that we should have a network of institutions, including industries. Academic institutions can give the scale-up procedures. Industry will give you money, and they want results on dot. Okay, they want results. They don't give money just like that. In government systems, if you are from a very famous allied institute, nobody asks you questions because you're from allied institute. So even if you waste the money, nobody asks you. But this is not the case with industry. Industry will hold you accountable. So thank you very much for making this point. Now, what I'm going to do, Dr. Sonde is looking at me angrily. You missed some point? Oh, okay.
No, I only want to say one thing. I mean, India's systems are good because I don't want you to get into this thing that our funding is bad or R&D is bad, because somewhere that kind of a thing, that what happens in the outside is bad. No, I have been a witness to this. Wonderful work is happening in this country. Believe me. Now you may ask me, you may ask me why then we are not able to deliver the cutting edge results. It is somewhere else, and that may require which are the valleys of death. That we've got about 2 valleys of death which happens at TRL level 3 and 1 happens at TRL level 7. But that requires to be analyzed why these valleys are there and how we can actually bring that particular expertise that we can parachute from TRL level 3 to 7. So just wanted to say that our systems are equally good. As much bureaucracy is there in every government. In fact, Western governments have much more bureaucracy than what we have.
No, thank you very much for clarification. Ranjit is very happy that you made this comment. That is a fact. DST has very good system. Yeah. We are very nice system. Our systems are good, but we are little slow. Yeah, we have to be fast, But anyway, now what I'm going to do, I'm going to invite questions. Some people are looking at me. So standing person, yeah, you okay. So now let me count the number of hands going up. So we have generated a lot of interest here. But restrict your question. Let it be clear. Don't give your bhashan here. You ask the question only. Okay? Okay, that's what I want to do. Because sometimes the people, they talk longer for the question than they answer. Yeah, please. Only simple question. And who among us?
Can I?
Oh, yeah. So
I'm happy that this panel is saying what I said in the 2 open forums, and Bhupendra Ballaji gave me a nasty look for asking that question about blind spots and failures. So thank you for that. And the morning with Gauri Singh ji, I was telling her, forget green, let's do black hydrogen. So thank you for that. The blind spots that I'm seeing that this panel has not addressed about this ecosystem is that it is talking about 2% of the universities. It's talking about 2% of the industry. For example, BARC has an Akruti program which tries to commercialize or bring the technologies to communities. It has failed miserably. And I've requested Daniel Babu and others that to give me a chance to do that. So we are not seeing what we are not looking at what we are not seeing. We are not reflecting. We're not having folks like Dr. Kim come and tell us, hey, you guys are doing foolish things or you're missing that. We need that. So Kabir was saying, Kabir, I'm also professor like you. Hey, we are so Professor Ahuja said we are not having enough risk. So what are the things that we are not able to embrace risk? As a professor of risk management for 9 years in L&T Institute of Project Management, except for Mr. Naik, I tried to bring in that appetite for risk. That risk appetite is not there. And there's only one single thing for it. And I think the challenge in India is too much education. I feel that the risk appetite of people who are not educated, in IITs especially, they have a very high risk appetite. And I have worked in a small university where I spent 5 crores in 3 months.
Now your question is what? Risk. Your question is risk.
Can we convince Professor Ahuja before he leave that we have a plan to increase the risk appetite of our ecosystem?
Yeah. Professor Ahuja, yeah.
No, that's what we want. And we want to give for that risk chance to young people. So they should take risk and we should fund it. Thank you.
Yes.
You see, listen, nothing is 100% successful. Then we would have achieved everything. Our problem in India, we give up easily. We give up on our people who are trying. We don't give them another chance to try. That is our problem. Okay, please. You identify yourself first.
Sir, can I? I was the first to raise my hand.
No, just 1 minute. You have to take risk.
I'm from BVK Hydrotech. We actually manufacture electrodes for electrolyzers indigenously developed. My question to you is, for a company like ours, for a private company like ours, what would be your suggestion? What would be the panel suggestion to ensure that we are able to successfully collaborate with institutions for R&D development of something which is so key in today's material science?
Yeah, my take on this is very simple. Identify the individual who has delivered, or we don't go by the name of the institute. It doesn't work that way. The individual matters the most in any system. So identify who is working in that area and go and tell and give that person the toughest problem. And you say money is not the limitation. We want results.
And in the time is a limit.
Of course, time. Yes, yeah. That is with a time-bound project, not. So you can do that. There are many people who will do your job. Okay, so you have money, a lot of money. So there are good people. Okay. Next you.
Okay. So.
What is your name?
A small startup which wants to build ecosystems. Demex Clean Energy. Thank you.
Okay.
And fellow
Thank you.
European School of Governance.
Thank you.
Thank you. You know, he forgot his name. He's such a professor.
All right.
Okay.
May I? Okay. So it really doesn't matter who I am. What matters is my question. And that is
Still, I want to know your name.
Yes.
Sir, I met you yesterday during lunch.
Audience doesn't know.
The audience has to come to me and ask me who I am. And that really doesn't matter. What matters is my question. Please try to understand. Please. Okay. Thank you. Thank you, Dr. Pai. So my question is to Dr. Sonde and also to Dr. Chetal. And why is no one talking about nuclear hydrogen? You know, I mean, my estimate is the podium on which the speakers are sitting, the size of this room would generate about 30 megawatt, number one. And number two is, are we expecting it anytime soon? Will it get approval and so on?
Yeah, may I respond to this? See, I've learned a hard lesson from my research to a commercial, to a private sector, to everything. Ultimately, it's a stupid economics. Okay. We can go out and say that nuclear is the savior, and we said 30 years back, 50 years back, fusion and everything has been talked about. If it has not happened, it's because you are not able to deliver the end product at a level where the market can absorb. Because end of the day, it's the market which is going to determine. And unless you do that, anything that I talk about is a great thing about whatever technology that we talk will not run through this whole thing. Similarly to photochemical, artificial photosynthesis, so many things were done and they were abandoned when the STH was just less than 0.3% and nobody could go beyond 1.5%. Similarly, in the case of nuclear, whether it's the SMR getting into hydrogen, is a good thing. Thermochemical, what he's saying, so that you don't get into the electricity. I can talk in a conference, but when it comes to the hardcore numbers that you want to deliver it under $1 is difficult. Unless you crack that problem, you will not get this particular. That's a simple answer. I don't know to decorate it with anything else.
Let me add. Sorry, yeah, please. Remember, we have time limit. I have been warned. I won't get lunch.
So let me add here that when you say hydrogen and nuclear, it still does take place in the world. If you produce the electricity from the nuclear power station, and if you do the electrolysis to a layman, it is called hydrogen from nuclear. India also has a plant, but that is not really the hydrogen when we say nuclear. When we say nuclear, people are talking about converting methane to carbon plus hydrogen at high temperatures. It is still very expensive. It is still not called green, unfortunately, in this country, in the world. Until unless the word green becomes really a change that you produce hydrogen, it has one different color is there. So submission is that India also has plans to make the hydrogen from the water using slightly hot water. If somebody says that is a nuclear hydrogen, answer is yes.
Nuclear coupled with SOEC.
Yeah, that's a different matter.
Okay, solid oxide. Okay. Professor Vijay. Yeah. Well, Mike, yeah. Are there?
I have a suggestion, not a question.
Ah.
This is a huge conference with so many participants from industry. We should have sessions on material challenges. Thank you.
Very good. So I will suggest to MNRE, okay, that M should stand for materials, right? Okay, they will do it. Mr. Venkataraman, please. अच्छा ठीक है वेंकट साहब.
Quick one on Professor Ahuja. Hit the nail on his head. And was very candid. Worked abroad, and then my question will come soon. I can guarantee you that. What I'm trying to say is there is a gap between tier level 3 and 7 or 9. It took us 20 years to bridge that. In spite of the fact I worked abroad and brought the technology to India. So there is a lot of engineering work is to be done. So my question to how do you take it from here to there? Industry participation. But industry knows only to tell you what they want. They can't tell you how to engineer it. So we need a little bit more than that. I think we need to have an APC guys also involved. So that we take it to a technology level. I think material science very important, not because my son has taken it, but I'm saying this is something very much lacking. I like Professor Yadav's M stands for material. That's it. Thank you.
Thank you. Yeah. You say no. Yeah, I have to give chance to a lady there. And then Shankar, I will come to you because you're a foreigner. We'll give a chance to you. Okay.
So thank you for the opportunity. I work in the same company as Mr. Ketan.
Sorry. Then he has already asked the question. You want to give money?
No.
Okay.
See, I work in research, so we deal with knowledge, not money. He's given the opportunity to a young professional, like you said, straight from academia, straight to industry. And we've been speaking to a lot of academic institutions, not looking at the name. But, for people who manufacture core components to the electrolyzer and not the electrolyzer itself, how do we bring about test setups to our company? How do we make sure that there is this distribution of knowledge? Because everyone is very cagey. I also studied in Switzerland, and we had competence centers in university where we, directly worked for industry solutions. When can we bring about that change in India?
Thank you. Thank you. See, this is policy, right? This is all policy, government policy. So experts who sit on these committees, they have to suggest to the government. Like he said in his talk, 300 plus components are required for the electrolyzer. Yeah.
If you develop some technology, you have to know your upstream and downstream, because you cannot sell your material directly to stack company who is only assembling. So you have to give that to an Emirate electrode assembly company. So there's all those mistakes, and it is difficult to find who is doing what. So I think you have to find it first, but you can have some good, advice from who already knows that.
Go to Madras Park in IIT Madras. We'll see a lot of
Thank you.
there.
Last question. Okay. Ranjit, only two, because he's also foreigner. Yeah. And no, Shankar is there. Yeah. No, Shankar, I should give chance to Shankar first, because he was in the queue. Let him speak. He has come from Canada, so let him. Shankar, please. Yeah.
I don't know whether coming from Canada is support at this time mainly. I'm sorry, can I sit and talk?
Yeah, no problem.
I'm health-wise, I'm all right. So just to mention that. So it's very interesting. We brought many topics, and material is one of them, of course. And in that case, one of the first things that I like was at the highest level of the country, Mr. Sood, Dr. Sood. I got a call from him after that question I asked last time. And he has fixed an appointment, and he said, look, we want your inputs, and let's see what we can do together. And he also mentioned that he has got a support from the PM's office to move forward on this. India is taking particular focus on things. I think one of you alluded to a TR level. Actually, my project, which has been approved as HVIC in the state of Kerala, they're putting a lot of money on front. It also has a debt equity component other than the grant that's given. It's a TR level 9. I already have 100 metric tons per day plant, kilograms per plant, and then I'm now going in for 1,250. And like you said, we are linking it to two other things. One on the fuel cell and power generation, and also a dispensing system for the fuel for Cochin Port Trust people. So why it can be linked. And I hats off to people now in DST who are working hard on that. And I think I could be an exception to start with a TR level 9. But hopefully I will be able to deliver. And I had people like a very good friend, an IAS officer. I happened to be one many years ago. But having said that, his name is Jyotilal, IAS. That's the type of guy who is required for such planning. I've been telling him, come over to MNRE. So he says, no, until the Kerala government is going to leave me. But all said and done, we cannot influence such good people. I'm not talking about specifics here. These are the people required for planning at the highest level in the country, because nothing moves without him.
Thank you. This is all recorded, huh? So they will show it to the government. Okay, yes, please.
Okay. Good. My name is Rolf Bent. I come from Germany, but I'm obviously a fan of India. I have a question to each one of the panelists, and that is with one sentence to say, what is the key thing that you would recommend for R&D and D to improve in India? One sentence, one thing.
One word. Collaboration. Yeah, no, no, he is looking at me angrily. Go ahead.
I'm Dr. Bonari Mallikarjun from Manipal Academy of Higher Education, sir. So my question my question is to Dr. Chetal and Dr. Ahuja, and to you also, sir. Collaboration. So while applying for grants, collaboration with industry, post-institution contribution, and the government contribution, would it promote the pressure on the PI to deliver the project? Because Chetal sir said, like when we are developing some product, final delivery is to be considered as the main. So that's why risk also comes.
So we start with Professor Ahuja. Yeah.
So you are saying right, what collaborations fits also here well. So you have three partner here: industry, academia, and the government. So I will say that if they are all three on the board, the proposal should be funded and it should be deliverable, and there should be caveat there, the risk involved. That should be there, because otherwise they will see this as your failure. You will not get next time funding. So that's what I'm saying to that. The failure should be taken as a positive step, and then only the industry, academia, they can work together. Otherwise you will not work, because you say I cannot deliver. So I will, because this will be a negative point for me.
Dr. Chetal, please.
I would like to say here, in fact, I had in my text, we should be having the projects of larger magnitude with industry as the principal investigator. Today, unfortunately, I understand that industry is not given the role of principal investigator in getting the fund. Industry should collaborate with the academic institutions to do the job, because you have better feel of how to do jobs in time. So submission is in this country. We should switch over that all the projects should be given to academic institutes. I would urge that the larger projects be given to the industries where we are going to TRL level 8, and let the academic institutions reputed one become partners. But the responsibility of doing the project in time within the cost should be with the industry partner. Not, let me tell you, difficulty in the country is a person on the road says that I am from the industry actually. I've been part of the DST thing. When we say industry, I mean industry, not a person who is fabricating a vessel on the road in Ludhiana. He says this fellow is supporting us. So let us.
Yeah, no, this is bogus thing. So I will give you the last word, okay? Because I'm the chair.
Last one.
Yeah, the last word. I would suggest that the Indian industry must define the problem clearly, because definition of the problem is very difficult. And then they come and they identify maybe 4 or 5 people compete for that project. They choose one, then government DST supports that the other part. That will be the best model. Then right now DST announcing the project, inviting the proposals and asking the fellow to get some industry partner. That fellow gets somebody somewhere there and he says, oh, I'm giving in kind. This kind means coming cup of tea and having something. That is not kind. Industry must define the problem, announce it publicly, and now we have ANR. That is the model they should adopt. That industry will tell, I want this solution. I can tell you, I went to them several years ago, and Dr. Baldera said, we are our people, ICT, we all went there. They told us that these are our problems. Can you help us? And we said, I will do this, he will do that, he will do that. And that is how we delivered it. That is the model. So their problem must be defined. So young man, don't get worried. Okay.
Later on.
No, later on, because now listen, lunch, everybody is leaving the room now. Thank you very much.
Thank you so much, chairpersons, for chairing this session. It was indeed a very knowledgeable session. And now it's a time to give a token of thanks to all our panelists out here, a token of appreciation. Can we get our hands together for all our panelists out here? It was indeed a very knowledgeable session. I would now like to request Professor G.D. Yadav to kindly present a beautiful memento to Professor. Are we starting from here?
Yes.
Okay. So, yeah. So, Dr. Sai Hoon Kim is out here. Loud applause, please, everyone.
Job well done.
I request Professor Dr. R.R. Sonde to please come forward and give us a chance to give a token of thanks to you. Loud applause, please. Then we have Mr. S.C. Chetal. I request Sir to kindly honor him by giving this a token of love or a thanks from our side. Loud applause. And in the last, we have here with us Professor Rajeev Ahuja, a silent man with less expressions. Now he's smiling. Loud applause, please. And can we get our hands together for our moderator, Professor G.D. Yadav? I request our knowledge partner, Ranjit ji, to kindly honor him. Loud applause, please. So we've got Dr. Ranjit Krishnapai, another smiling face. I know. I know. Professor Yadav is waiting for lunch. And dear all, it's a time for lunch. We're going to reassemble here before 2 o'clock so that we can start our session exactly at 2. So I request you all to kindly reassemble here for another session. And that is also going to be an interesting one, as the topic for the same is US Cooperation on Green Hydrogen Sector. Thank you. Reassemble, please, before 2 o'clock so that we can start at 2. Thank you so much, everyone, for joining us. Thank you.
Actually, a couple of years ago, I asked Simon that I'm from India. The moment I told, they said like, India requires immediate payback. Another thing about the technology development, we work with the academia and industry. That's why we are able to suggest a model. I work on that model. So I'm professor. This is mine, isn't it? I don't know. In Jaipur. Yes. Even before the song. Okay, just 1 minute. We have been awarded 600 megawatt project for 820%.
Big answers.
Put it on project, 180. It can be also how we can also. What I'm offering is here. Yeah, that's what you already coming from.